This is the start of section 2.5, day 1. Pretty important section. We're talking about two different theorems for the most part. One of them called the fundamental theorem of algebra. Whenever you see that word fundamental in math, that means it's really important, that it is the basis for a lot of different things. Here's what the fundamental theorem of algebra says, is that a function with degree n, a polynomial function with degree n, has n complex zeros. So what that essentially means is if it's got a certain degree, that's how many zeros it has. For instance, a fifth degree polynomial has 5 zeros, and that's going to be whether they're real or complex. We're going to talk more about complex or imaginary zeros in a little bit, but just know that if it's got a fifth degree, it's 5 zeros or 5 solutions. If it's sixth, it has 6, and so on. Now, that's the big basis for everything that we're doing today, but something that goes along with it is called the linear factorization theorem. Basically saying that if a polynomial has these zeros that we're talking about, the 5 zeros, is that they can all be written in a factored form. So we've got, well, this kind of just arbitrary one here, this x minus z1 and so on, meaning it's got all these different zeros, and we can write that factored out. You'll notice there is an a out in front, leaving room for a coefficient, but basically we can factor it and we can write them all out in that form. So polynomials with any zeros, real or complex, can be written in factored form. That's basically what this is saying. So if a fourth degree polynomial has the zeros 1, 2, 2i, and negative 2i, even though they're imaginaries, we can write them in factored form, make it look like this. Each zero has a factor. Now there is, again, a coefficient possibility out in front. That's not super important for this, but it's just make sure that we can consider various situations.